In this video, we are going to learn about how to make a net for a geometric solid. So the technical name for any 3D shape is a solid. So for example, cubes, cylinders, and pyramids are all solids. In 6th grade, we're going to be really focusing on prisms, which are types of solids where you have two congruent bases connected by rectangular faces. That sounds complicated. They're really not too hard to recognize. So a cube would be a prism because it's all rectangles and two of them are parallel and congruent. A cylinder would not, because the sides are rounded, right? Like a tin can. And a pyramid would not be, because it has one base and then it goes up to a peak at the top. So that would not have two congruent bases at the top. If it had one base at the top and then one base at the bottom, and then the sides were connected, that would make it a prism. So any solid has a net, which is, most of them have more than one way you could make the net. The idea here is that if you were to cut open the solid, picture it hollow and cut it open, and then lay it all flatten it out, then you would have a net. The net should be able to be folded up to recreate the solid. So I've got a picture of a net to the right. What could you fold that net into? What shape do you see? Did you say a pyramid? So you can maybe see how if these sides folded up here, so that all the sides were folded up, and then all these points at the top would meet with each other to make the peak of the pyramid. All right, so now we're going to practice drawing some geometric solids and nets for them. So let's start with a rectangular prism. So you may have a different strategy for how to draw a geometric solid. I like to start by drawing the front face. We're going to make it a 2x5. And then I'm going to draw some lines to show it going back that are going to be the same length and the same direction off of each of the corners of my rectangle. So I'm going to go like that. Notice how I kind of went over 3 up 2. That. And then I can connect those to make my box. Now you have a choice. You can use dotted lines to fill in the parts of the rectangle that you wouldn't be able to see from the front if you like that. Or you can not. It's your choice. Kind of depends on what you're looking for. So now that we've got our rectangular prism, let's go ahead and draw a net for it. So we can see here that the first thing you want to do is count up the sides. That's how you make sure you don't miss any. So on this one, I see 1 in front, 2 on top, 3 on the side, 4 in the back, 5 on the other side, and 6 on the bottom. So I count 6 sides, which is always going to be true for any rectangular prism. And so then I'm going to try and picture what this would look like laid out. So maybe I'll start with that bottom face that is like touching the table, if you could picture it that way. All right, so there's my bottom piece. And then I can see that all around it, there are these pieces around the outside. So I'm going to go ahead and do those next. So the one in the front, looks like that. One on the side, one on the back, and then the one on the other side. And then I also have the top. And it doesn't really matter where I draw the top because it's just going to be able to like fold in from there. And I guess I'll do it the same color as the base since I know it's the same size. So we finish by counting our sides again, making sure that we got all 6 of them. And 1, 2, 3, 4, 5, 6, we did. Normally you would then go and label the measurements on your net, but we can save that for the next example. All right, next we're going to try and draw a triangular prism. So a triangular prism is different because the base is going to be a triangle. There'll be 2 of them, one on the top, one on the bottom. Or the way we're going to draw it this time, one in the front and one in the back. So let's start by drawing a triangle. Let's make it a base of 4 and a height of 4. And then let's do an identical triangle to that off in the back. And then you can connect all the matching vertices. This is not exactly the same way I had you draw it last time. It's kind of an alternative method. Notice how this way you end up with all the lines drawn in, even the ones that are technically hidden. And this time, let's go ahead and give our prism some measurements. So we drew this so that the triangle's base was 4. We also wanted it to have a height of 4. So I'll draw that in with a dashed line and a right angle. We also would need the side length of the triangle. Let's say that that's 5. And then we would need the height of the prism. This can get confusing because the height of the prism would be this length right here. It's different from the height of the triangle. It's like the distance between the bases. And let's say that that's 10. I think that's all the measurements we need. Go ahead and pause and see if you can sketch a net for this. Don't worry too much about the measurements being exactly precise. Just try and get it to look generally right and then label the sides with what they are. All right, so I'm going to start with the base here. And that was a 4 by 10. Then I know that there are these triangles that are connected on either side. So I'll do those next. And those had a height of 4. And then I had 2 more sides remaining because I know that I counted 5 sides to begin with. And they are both the same. They both are a 5 by 10 rectangle. Make sure you see why that's a 5 by 10 and not a 4 by 10. Really take a nice look. See how it's that 5 right here by 10. Can really help to draw it out and trace it. And then I'll have the same thing on the other side. There, same dimensions because it is an isosceles triangle. And if you didn't already, let's go ahead and label the dimensions. Labeling the dimensions is especially important if you were not able to draw it to scale using the grid on your grid paper. All right, now it's time for your practice problem. For your practice problem, you need to draw a net and label the dimensions for this rectangular prism that has a height of 1, a depth of 7, and a width of 6.